Hello class, I am Mr. Tiralosi. Today we'll be doing our lesson on rocks and the rock cycle. There are three main categories of rocks, sedimentary, igneous, and metamorphic. I'm sure most of you have heard that before, but we'll sort of take our time and go over them one at a time. We'll start with sedimentary rocks. These are, as the name suggests, formed from sediments, deposited materials, weathered rocks, even shells from animals that have been deposited over time and compressed to form a rock. Generally, they are made up of clasts, which are pieces, like I said before, like pieces of rock or sand or mud or shells that are held together by some sort of matrix. You can think of that as a glue or a cement that sort of binds the pieces together to form a solid rock. This isn't always the case, but many sedimentary rocks can be identified by the fact that they crumble. They'll leave residues or streaks when rubbed in your hand or rubbed against something. Just a quick identification for that. And they are typically what are used by scientists to look back on the history of Earth's surface to determine what may have happened there at some point. Things such as fossils, which would have recorded plant or animals, sandstones or shales, which would have determined what type of environment was in a certain place at a certain time, things like that. The next type of rocks are igneous rocks. These are formed by cooled and crystallized magmas or lavas. The difference being, as some of you may know, magma is what is called before it leaves the earth, and lava is after it leaves the earth. Similarly, intrusive rocks are formed inside the earth from magma. They cool or crystallize more slowly, and so larger crystals have the opportunity to form. The opposite would be extrusive rocks, which are ejected from the ground in some way, sometimes through a volcanic eruption, sometimes through separation of two tectonic plates, and they cool relatively quickly. These rocks can tell scientists sort of long-term history of the Earth, how plates have moved, what type of composition is inside the Earth, those types of things. We have here an example of an extrusive rock, pumice, which can form from lava forcefully ejecting from a volcano. These rocks actually cool so quickly that they're mostly full of air. You can see the sponge-like texture. They can actually float on water. Intrusive rocks, such as granite, can take millions of years to cool slowly underground and have very clear, visible crystals to them. The last type of rock is metamorphic rocks. These rocks form from other rocks through a process known as metamorphosis. Usually this happens deep underground. in high pressure and temperature environments. And because of this, we can trace back what the rock originally started as or where it was, and we can trace movements of underground crusts and plates through that. One signature of metamorphic rocks is that oftentimes the high temperature and pressure can cause foliations or bands to form in the rocks. This happens because under high consistent pressure and temperature, minerals will tend to organize themselves in rows. And so this can either mean bands of different minerals through a rock, as you can see with the gneiss, or it can mean that the rock forms in sheets that can peel apart in a lower grade rock. So here we have some examples of rocks. I'll give a brief description of each rock, and you guys can try to tell me what type of rock you guys would categorize it as. So we'll start with the schist. It's a hard rock. You can see some minerals in it, and it is. You can clearly see some streaking through it. That's right. It's a metamorphic rock. You can see the minerals have sort of organized themselves and been compressed in clear rows. Next, we have obsidian. This is commonly known as natural glass. There are no visible grains. It's very similar to glass, smooth and breaks the same way. Yes, that's good. That's an extrusive igneous rock. It cools so fast that there's no visible grains at all. Next is chalk. This is a powdery sort of rock. You all know what chalk kind of feels like. It leaves a powdery streak behind. Yes, that's good. That's a sedimentary rock. And graphite, similar to what we use in pencils, but it's no longer used in pencils anymore. It leaves a gray silver powder on paper and on your hand. Yeah, good. That's also a sedimentary rock. And here we have the rock cycle. This is sort of the overarching concept that shows how rocks can form. As you can see from a brief look, all of the arrows go both ways. So yes, all rocks can form from other types of rocks. As sedimentary rocks form from sediments, any kind of weathering and erosion from either a metamorphic rock, igneous rock, or other sedimentary rocks can deposit and compact into sedimentary rocks. Similarly, any type of rock, igneous, sedimentary, or metamorphic rock, can melt into magma and then crystallize either extrusively or intrusively as igneous rock. And again, metamorphic rocks, as we already talked about, can form from any other type of rock from being buried with high temperature and pressure.